many aspects of several data structures have been covered so far. Now, we will discuss about some algorithms which extensively used on collections. Those collections usually can be stored in the form of an array or linked list or trees or whatever it is there. Now, we have also learned few algorithms in this regard while we are discussing the different operations in order to manipulate the data structure or data in a given data structure. Now, we will discuss in this module some algorithms which are related to some operations, of course, but we will give a specific algorithm. Those basically have received many attentions from the computer scientist to improve the best algorithm for the purpose. It is related to searching. So, our today's topic is basically searching algorithm. So, we will discuss the different concept. Okay, we will discuss the different concepts related to the searching, different searching techniques, and there are varieties of searching techniques are known. So, in this class, we shall discuss three important searching techniques, namely sequential search, binary search and interpolation search. So, today it is our plan. Now, let us start about discussing the different searching techniques which are known till time. These topics in fact very vast, because since the inception of computer, particularly the programming, the many computer scientists have evolved with many algorithms. Every algorithms have their own benefits as well as certain limitations, but still the process is on so that we can have better searching algorithms. Now, let us see the total story of several searching algorithms which has been evolved till time, and I have given a taxonomy of different searching technique. Different searching technique actually follows certain principles. Anyway, whatever the searching techniques are there, they can be broadly classified into two categories. They are called internal searching and external searching. Now, external searching, when data is stored in memory, but it is in secondary memory, it is in hard disk like or floppy or some external storage devices like tape, whatever it is. On the other hand, internal searching techniques, when data first loaded into your computer memory and then you apply search algorithms. Now, in this course, we will limit our discussion to only internal searching techniques, because external searching techniques needs the different treatment which is beyond the scope of this course. Now, again, internal searching techniques, those are available, can be broadly classified into two classes. They are search with key comparison and another is search without key comparison. Now, so search without key comparison means basically we will not require to compare two keys while we are searching for the target key. So, that is without key comparison. We will discuss how searching without key comparison can be accomplished. The next is search with key comparison. In this class, there are several searching techniques are known. Now, again, all searching techniques belong to this category, can be broadly divided into two classes. One is called linear search, another is called non-linear search. There are many techniques belongs to linear search, namely sequential search, binary search and interpolation search are the three most important searching techniques, which are called searching technique belongs to the linear search. Now again, non-linear searching techniques, there are many. In case of linear searching techniques, we usually store data into a linear data structures. Linear data structure means maybe array or linked list. On the other hand, for the non-linear data structure, the data are stored into a non-linear data structure like tree or graph, like this. Now, so if your data is stored in tree type data structure, then different searching techniques can be applied to, which are, for example, binary tree search, or it is called the binary search tree search, the AVL tree search, red black tree search, splay tree search, digital search. There are certain other searching technique where in lieu of binary, it is the multi-way searching. So this is called the M-way searching. For example, B tree search, B plus tree search. In general, they are called M-way tree search. Now again, the data, if it is stored in the form of a graph, some searching techniques also can be applied. Two searching techniques are very popular, like depth first search and breadth first search. So there are so many searching techniques are known. However, in this course, it is not possible to discuss all the searching techniques. If you are interested to learn different searching technique, including external search and whatever the searching technique, then I should suggest you to follow the book Classic Data Structure chapter 11, where a thorough discussion about all searching techniques have been given. So those are interested students, they can follow this book for their further studies. In this course, as the time is limited, so we shall limit our discussion to only few important searching techniques. I have mentioned what are the searching techniques that I will cover in this course here. So first of all, searching technique with key comparison belong to this linear search and non-linear search. Under the category of linear search, we will study about simple linear search, binary search, and then interpolation search. Then in the category of non-linear searching technique, we will discuss about binary search tree search and then Fibonacci search. Now searching without key comparison, we will discuss one technique, address calculation search. Address calculation search basically follow the hashing concept, which we have already covered while we are discussing mapping, but here in the context of simple searching we will discuss this concept. So this discussion will complement already learned discussion while we are discussing regarding the mapping and tables there. So these are the plan for this module. We will discuss different things. Some portions will be discussed in today and some other parts will the next class. So now let us consider about linear searching. I told you linear searching is applied to data structure of type linear. So if you store the elements can be anything. It can be a number like integer or floating point number or short, whatever it is. It can be string, it can be character, even it can be user defined object of any type, but they are essentially stored in the form of an array. Now array we have already studied, that array is supported by means of different collections, as we have already learned, like arrays, array list, vector, and so many things are there. Even in your program also you can define your own array. So whatever be the collection is basically stored in the form of an array, and it is okay. If we have to search an item stored in the array, then we can say that it is the linear searching techniques. So data stored in an array, there are now the question that arises is that how data are stored. Now, data can be stored in two different ways. One is that it is in order. Now, this order may be in ascending order or descending order or some order. On the other hand, the data can be stored in a random order, no ordering. This is the one possibility that okay, how data is stored. Now, that can this kind of, whether it is in random order or ascending or descending order, it can be stored in the form of a linear data structure. Now, there are two versions of linear data structure, one is called array and another is also linked list. So, you can store the data into a linked list also in a random order, or it can be in a particular order, maybe ascending or descending order. So, depending on the type, obviously data structure matters as well as arrangement of the data matters, the different algorithms is possible. So, let us first discuss about the searching of data which is stored in a linear array, and we will first consider the data stored in a random order. As in this example, we can say this is basically array of integers, and as you see the number integers are stored in a random order. Now, the algorithm that we can follow, which basically is shown here in this flow chart. Now, here the data stored in a random array, and we have to find one item or elements if it is stored or not. So for example, a target key is 9. So, what we should do? We should start from this position. This may be 0th location or first location, whatever you can say. So, here in this flow chart, it is assumed that first location is location I1, and now we have to start with it, and then we have to compare whether the target key, that is our 9, is located here or not. If it is not here, then this pointer will move in this direction. Now, if we traverse the entire array and the item is not found, that means we reached here, then we can say the search is unsuccessful. Otherwise, if we find some element which is here, then we can say the search is successful, and in which location the element is available or present, it can be returned. So, this fact is depicted using this flow chart. So, this is very easy to understand. If you start with, you will be able to follow the logic that I told you how it can be done. Now, so this is the concept that searching with key comparison, and it is the linear data stored in the form of a linear data structure like array, and data are stored in random order. Now, we can extend these things writing an algorithm. I have written an algorithm for you. If you follow this algorithm which is given in this table, it will be easy for you to write the code. So, writing the code for this particular linear search is very trivial. Anybody can, having some programming aptitude, they can write this. So, I should not discuss about this programming. Whenever I come to the programming of different searching algorithm, there I will point it out. So, now you can go through this because it is so simple that no need to for further discussion. Now, let us consider another case where the data is stored in an array, some numbers for example, and it is already sorted in ascending order. So, like the previous searching algorithm, it is basically same. Now, here we start from the first location. So, this is the starting location, and the target key needs to be compared. If it is available here, then we will stop it here, we should not go further. Otherwise, we will scan it, and if we do not find the elements here, then we can reach here at the end of the array, giving the search is unsuccessful, otherwise search is successful. Now, idea is more or less similar to the previous algorithm, but here actually, so here if you find the element, or if you see that your element which is the element that you want to search is already exceeds the limit. For example, we want to search say 5, for example 5. So, we can start from here, you can reach here, and then we can find that 5 is available here. Now, suppose we are searching for some numbers say 3.5. So, we can search again 3, Now whenever we come 4, we can say that moving this direction will not be fruitful, because the element that we have searching are not possible to be here, because we have already crossed the limit. So because 3.5 should be here in these sites only, not in these sites. So we can stop the searching. That is the only difference from the previous one and this one, because in case of previous one, as data was in random order, we have to start searching whenever it is available or not, okay, or not available, like, okay. So this is the only difference that you have to take care in this case, and accordingly you can decide the algorithm. I have given an algorithm for you. This is the flow chart, and then the algorithm is, okay, you can follow this algorithm, the same algorithm, simple logic, and it is easy to implement. Writing program will not be a big issue for any programmer. So this you can try to write the program storing the elements in an array and in a sorted fashion, and you can repeat the same thing starting with the ascending order as well as descending order. Logic will work in same way, but you can check it, okay, if the data stored in an ascending order or descending order, whatever it is there. So you can just have the idea about simple linear search. It is really simple because idea is so simple and logic is also not so complicated, and you can do it. Now let us come to the analysis of this searching algorithm. So what is the time complexity or the running time that is required? Now we are assuming that data first of all stored in a random order in an array. So in the best case, so this is the case 1, which we can say the best case. In case of best case, the total time that is required, you can say 1 unit. I am telling unit because it is basically only to search the first element and stop it there, assuming that the element that is your target element is available in the first location itself. So this is the best case or ideal case, of course. Now on the other hand, suppose the element is not present in the list, then you have to traverse starting from 1 to n. So total cost of traversal is basically, you can say n unit, or you can say the total time complexity is n. And on the other hand, if k is present, but if k is present, it can be located at any position. So if it is available in ith position and pi is that probability that the element will be in ith position, then we can say that this is the total time that is required. Now, so now we can take the summation for all I equals to 1, taking the average. So it will give the average time that is required, assuming that p1 to p2 and are equal probability. That means element probability that the element will be located at any position are equal probability. Okay. So then we can say that all probability values are 1 by n. So this calculation therefore can be calculated is a simple manner is at n plus 1 by 2. So on the average, half of the elements needs to be moved or traversed actually. This is the best, the idea actually there. So these are the 3 different cases. This is the best case, this is basically the worst case, and this is the case, it is called the average case. On the average it will take like this. So overall the complexity, that actually time complexity, what we can say it is order of n actually, that is the asymptotic complexity. Now I have listed all the asymptotic complexity in this table for your summary, you can follow it. So the case 1, that is the best case, as I told you, Tn equals to 1. Then complexity, it is an asymptotic complexity notation or big O notation it is called. If you are not aware about the big O notation, then you should have this concept actually. Any algorithm book can be consulted, including this classic data structure also. You can follow how to express the complexity of an algorithm, that is called asymptotic complexity. There are many notations, big O notation, theta notation, big omega notation, small theta notation, like this. So that actually I advise you to go through a special chapter 11 there, and you can find the complexity notation for the different algorithms that you can have. Now anyway, so this is the Tn in big O notation order of 1, because it is require constant time. Whatever be the size of the array, it is constant, only the fixed time it is required. But other techniques, whenever the other cases rather, other than best case, that means worst case and average case, the complexity is in the order of n. This means that the time, running time of the algorithm will increase linearly as the number of elements stored in the array increases. So this is basically linear time complexity we can say. So, these are the complexity analysis details how this complexity analysis can be calculated, that you can follow the book Classic Data Structure for detailed discussion. Okay, so this is the idea about the simple linear search, rather we can say simple technique. Now, let us come to the discussion about again another linear search technique, but when the data is stored into a linked list data structure. We are already familiar to linked list data structure, and possibly we have discussed about the search operation there. We defined one data structure called linked list, where we defined many methods, insertion, deletion, possibly searching also have included there also. Anyway, the same concept it is there. It is similar to the linear array because like this, but we have to traverse not consecutive memory location, rather to traverse to the next node depending or following the link that is maintained by the previous node. So, this is the concept it is there. Now, searching it will takes place as usual, starting from the first node. You can first check whether your target element is present here or not. If not present here, then we have to move in this direction, and we have to repeat this until we find the element in a particular node or we reach to the end of the node, I mean end of the list rather we can say. Okay. So, in this case searching is unsuccessful, otherwise searching is successful. Again we are assuming that data here stored not in an order, it is in random order. So, this is the basic technique, and then an algorithm also you can follow. This algorithm is given for you so that you can implement this algorithm. The same algorithm we have possibly implemented while we are discussing about the linear data linked list structure, right. This algorithm again pretty simple, that can be implemented easily, and when the data are stored in an order, assume that in ascending order, how the algorithm works it is mentioned in this algorithm. This algorithm you can follow. It is basically the same as the linear data structure with array that we have discussed. Start from the first node and we can move to the next depending on two conditions. One condition is that the element is not found or element is less than the target element, that is we are going to find it. So, whatever it is there we have to continue, and we stop under two situations, when we found the element there or we reach to the end of the list. So, these are the conditions, and this algorithm is basically ported the same concept, and you can follow it easily. This algorithm is English like sentence, not exactly in Java programming syntax, but you will be able to easily convert this into Java programming syntax. So, this is again writing program for this is left as an exercise for you so that you can practice it. Now, here the time complexity for this purpose, as you can see, it is similar to the previous one. So, this is the base case, is a fixed time. This is basically the average case, as usual it is n plus 1 by 2, half of the list to be traversed actually in general, and worst case this basically either element is available at the last node or is not available in the thing. So, the worst case is this one. So, these are time complexity. So, what we can say, the time complexity for linear search and your linear search technique with array and with linked list are almost same. So, they are of similar complexity. That means we can say that the algorithms which we have considered for searching over an array or over a linked list are same level of complexity, or running time will be almost same, and in both cases it will basically proportional to the number of elements stored in the data structure. Now, so we have discussed the different searching technique, linear searching technique rather, when data are stored into a linear data structure namely array or linked list. Now, we will consider another better searching technique. It is basically the same, the element is stored in an array. We can apply the same thing on the linked list also, but popularly this technique is applied to data structure when data is stored in an array data structure. And another condition we will follow for this searching technique is that elements are stored in an array and already in sorted order. So, if the elements or data is stored in an array and in sorted order, then we can devise a better searching technique which will work better than the linear searching technique that we have discussed. Now, let us follow the techniques that we are going to learn about how it works actually. So, the idea it is like this, it is already sorted. So, we know the first location of the list and the last location of the list. So, first what we should do is that we have to hit at the middle location. So, hit at the middle location means which is at the middle position of the array. Now, your target key can be compared with the element which stored in the middle position. Now, two situations will occur. One is that element is present, therefore matches, so stop the searching. Another thing is the element does not matches with the elements which is at the middle location. Then what we should do? We can repeat the same procedure, but not on the same array, rather one half of the array. Now, which half you have to decide that whether the element, the target element which is less than the element which is at the middle or is greater than which is at the middle. If the target element which is less than the element at the middle, then we should start the next part of the location. So, this part, okay. So, in this part we will search it. On the other hand, if the target element is greater than the element which is present at the middle location, then we should search the element at the rightmost part of the list. So, it depends on the target element, and this procedure will continue until we come to a list which is no more splittable. I mean, we will not be able to divide into two parts. That means it contains only one element, or you already find an element, that means matches occur. So, this is the case that you can think about it. So, each time you split the array into two parts, at the middle compare, then either check the left part or right part depending on the number that you are searching. So, this basically the idea about the binary search technique is very popular searching technique. The algorithm, the procedure that I told you is stated in a more systematic manner in an algorithmic fashion. So, this algorithm is pretty simple, and if you follow, you will be able to understand how this algorithm actually work. And finally, writing program following this algorithm is also very simple. It's okay, it's not a tedious job. It is also advised to you that you can try to write the program based on this algorithm, so that you can practice much better and learn the concept much better. Okay. Now the complexity analysis. The detailed complexity analysis is very difficult job. I will just tell you that binary search basically follow a recursion tree like this one. So, this is the middle location, then if you find it, and if you find it, stop here. If it is not find it and the target element is less than, then you go there, and so on, so on. So, this basically the idea about we have given the idea about for the elements of size 10, I mean array of size 10, and then how it will occur. So, if dependent is a failure case, otherwise if you find it, the equal cases is there. Now, so this is the idea that is there. So, it basically is a tree, and so whenever you search, the longest path that is in the tree is basically total complexity, and you know this is just like a binary tree, and the longest path that is possible, and it is almost height balance tree, we can say. It is a basically height balance, or we can say in this case, for example, it is a complete binary tree. So, complete binary tree is the good for minimum height that you already know. So, in this case the height will be the maximum path length that is possible, and which is basically log n if the n number of nodes are stored in the tree like. So, this is basically log n, and considering these things, the search complexity of this binary search tree is basically order of log n. Now, and in case of best case means if you find the element which is present at the middle location, So only one probe is required. The best case is basically this complexity, whereas the worst case is basically this complexity. And a recurrence relation that we can write it, recurrence relation is basically this is the task that is required to find the location, that means middle position of the list. And then once you calculate the middle position, you can stop it or you can continue the same thing but with the half of the list. So recurrently this expression can be said that Tn is equals to 1 plus Tn by 2. Now we can express this again, this is basically 1 plus 1. If it is not found in the either left part or right part, then you have to repeat it again, but in this case your repeat will go on for the 1/4 of the list. So each time as you progress, so number of size of the part of the list is reduced. Now if you suppose not available in the 1/4 of the part, then we have to continue again. So now next again, so is recurrently we are resolving, then in that case it is basically so T and it will go n by 8 we can say. Okay, so n by 8 means is 2 to the power 3. So is a 2 to the power 2, 2 to the power 3, and if we continue this way, so 1 plus 1, so it is up to k number of 1 up to kth 1, and the next will be T n by 2 to the power k. Now the boundary condition is T1, that is possible when n equals to 2 to the power k. So suppose n equals to 2 to the power k, then what we can write is that 1 plus 1 plus up to plus kth 1 plus T1. Now here T1 is equals to 0, so we can stop it here. So we can say that this is equals to k because the k number of 1s are there. Now here, so k is equals to, this is equals to log 2 n. So this is basically we can say the complexity is log 2 base n. So this is the time complexity which is written here basically, but it is taking the floor, so log 2 n plus 1, because here we assume that n is exactly divisible by 2 or is a power of 2, but it may not be like that. So if it is not like, then we have the complexity like this one. Now here we assume that n is exactly a power of 2 actually. Anyway, so this basically gives an idea about the time complexity, this one. Now log 2n. Now you compare the searching algorithm that we have discussed when data is stored in an array using simple linear searching technique. It takes the order of n. So is basically, so this algorithm, the complexity of this algorithm we can say order of log n, and the previous time complexity that we have discussed is order of n. Now actually this order of n, this is greater than this one, that means this algorithm is better than this algorithm. So this is the idea about the sorting technique, searching technique and the binary search technique that we have discussed. Now let us consider the another searching technique. It is called the interpolation search. Interpolation search is basically an improved version of the binary search technique. In this search technique, the difference between the binary search and interpolation search is that almost the technique is same, but in case of binary search technique we have to hit at the middle elements at the middle position, but in case of interpolation search it is not exactly the middle. Basically we have to hit at the position which is very close to the target element, if any. So for example, you are to search for say 7.5, so in case of binary search it will probe here, but in case of interpolation search it will probe here. So this that the number of iterations or pass that is required will be far less in case of interpolation than the binary search technique actually. So this is an improvement. Now let us see how we can probe, which is very close to the target element actually. Now, so in this regard there is a interpolation formula calculation. Interpolation formula is there, so we can follow this interpolation formula and can apply it. This interpolation formula to check that which is the possible location which is very close to the target key. So k is the target key and k is the basically the bound in the lowest one and u is the upper one. So in this series this is the kl and this is the ku, and any elements basically your target element that you want to find, whether this is there in the list or not, and u minus l is basically location. So this is l and this is u. So this formula can give you to find for a given key which is the nearest location that we have to probe or hit. So this formula is basically important, and based on this concept, otherwise everything is same as binary search algorithm. Only the problem is that here we have to calculate the position where we should hit instead of pretty simple location, the middle location that is followed in binary search technique. The algorithm that you can follow, it is there, the algorithm is written here. You can follow this algorithm, same algorithm, only this part is different, the calculation here not middle actually, the interpolation location calculation, other parts are same. Now so far the complexity analysis is concerned, detailed complexity analysis you can follow any book in the classic data structure, also you can consider, you can find the detailed discussion. If the element present in the list, then depending on the best case, worst case and average case, time complexity will be like this, and if it is unsuccessful then this is 1. Now we can say that this complexity is on the average is log 2 n, now which is very less than log 2 n actually. So this means that this algorithm is better than the binary search algorithm that we have discussed. So this is the better algorithm, and a program you can write it. While programming we will discuss, this technique details there, programming issue will be discussed in another class. Now I have given a big comparison about the different searching that we have discussed about. Now as we see the searching over a list, either linked list or it is in maybe all elements are stored in an array, we can assume that it is in a sorted array, because interpolation required that elements should be in sorted order, binary search also required that elements should be in sorted order. Now here you can see, if we follow the linked list, as the time increases, I mean the number of elements increases, the complexity increases actually. If it is not exponentially, but it is increases with time. On the other hand, this algorithm is basically the algorithm for okay, so this algorithm is basically the interpolation search, and this is the time complexity that is required for the binary search. As we see, the interpolation search takes little bit more time than the binary search, and in this case binary search is very fast actually, although complexity is log 2 n. This is because in case of interpolation search, address calculation is basically heavy, that is why it is taking time. But anyway, both the algorithms are comparable and it takes okay, more or less same time, and you can see that as the number of elements increases, it does not increases exponentially as it is increases for the list over the search it is there. So this way we can check, we can see that which search algorithm is better, and that is why interpolation search is not so better because of this address calculation. However, binary search is the best searching algorithm so far the linear data structure is concerned. That means if you store the data in the form of a array or in a linked list, you can follow the linear searching techniques. Now I have given some basic concept about the linear search techniques when the data is stored in an array or linked list. There are few more techniques also available in this book. I suggest you to follow the book for further studies. Okay, thank you very much.